Hi, everybody. Welcome to this video on the top 10 network architecture decisions in OCI. My name is Rafi Shabazian, and I'm a principal cloud network architect working at OCI. Today, we have a very special guest with us, Cam Agayan, who's the Director of Cloud Engineering at Oracle. Cam, could you please take a moment to introduce yourself?
Hi, absolutely. Thank you very much, Rafi. Well, as Rafi mentioned, my first name is Cam, last name Agayan, and I'm responsible for the network engineering on the pre-sales side with Oracle Cloud. And today, we're going to talk about 10 key network architecture decisions that every network cloud engineer needs to make at some point in order to have a scalable network on Oracle Cloud.
Excellent. Thank you, Cam, for that. We appreciate you being here with us today. So as Cam mentioned, here is the table of contents. And as previously mentioned, we're going to cover this in a two-part video series. So for today's topics, we're going to go over the types of subnets, routing and OCI, cloud connectivity, some FastConnect Security, and connectivity to Oracle SaaS. In the future video, we'll cover the topics on the right-hand side, but this is what we have for today. So let's kick this off. So the types of subnets. Cam, right? So we've heard there's various types of subnets in OCI. We have some public subnets, we have some private subnets. Could you take a moment to go over the differences between the two, please?
Absolutely. Public and private subnets is a very interesting topic on Oracle Cloud. So that's one of the very first things that people notice when they come from other cloud providers to OCI. Generally speaking, we support two types of subnets, public and private. Private subnet is exactly what you need if your resources are on the cloud and they're working together. You do not need any inbound session from the internet. So no one from the internet is going to access your resources directly. Well, that works for many customers. But what if you want to have public IP addresses assigned to your resources and you want them to be reachable from the internet? Meaning, what if you wanted to have incoming sessions from the internet into your network? The answer would be a public subnet. With a public subnet, of course, you can have public IP addresses and connectivity from the internet into your subnet is possible. I can think of many customer cases that people want to have public subnets, and we can talk about multiple different examples. I think a very valid design is where customers want to have a scalable design with load balancers, but at the same time, they want those load balancers and resources behind them to be reachable from the internet. In cases like those, all you need to do is just assign a public IP address to your load balancer and make it reachable from the internet. That is possible with public subnets. So once again, just to recap, two types of subnets. One of them limited to private connections within your OCI footprints. The other one will give you access to from the internet into your resources, and that's the public subnets.
Excellent. So I think I heard an example, Cam, that you probably mentioned, what I would position in a private subnet and a public subnet. So it sounds like load balancers are more preferable in public subnets, and your backends, your targets, or your private nodes are more preferable in the private subnet. Is that a fair understanding?
Exactly. That's how we kind of position these two. Once again, if you have any requirements regarding access from the internet into your network and your OCI footprint, then the public subnet would be the best choice. And within that public subnet, you can make all sorts of decisions. You want to have public IP addresses assigned to your resources. You want to have load balancers, make it more scalable, put your resources behind them, and keep a combination of private and public subnets. It's all possible. But once again, access from the internet, what you're going to have to do is you need a public subnet, at least, to make those resources reachable from the internet.
Excellent. Thank you for that information, Cam. And
Sure.
I think a quick diagram architecture.
Exactly.
Let's quickly go over this, please.
Exactly. Oh yeah, that's a great example. On the right, you have a public subnet. As you see, for the public subnet, you do not need any kind of intermediary device. You have an internet gateway, direct access to the internet. So back and forth, you can have communication with resources on the internet. You receive traffic, you send traffic, no limitations. The other subnet on the left, that one has an interesting design. So as you mentioned before, this kind of subnet is not going to allow any connection directly from the internet into the subnet. In order to have access from the subnet out to the internet, you're going to need a cloud construct here, in this case, a NAT gateway. So your private subnet is going to use a NAT gateway to get access to resources on the internet. That's how communication happens on the left. And on the right, your resources can have two-bound communication, two-way communication with the internet via the internet gateway. Connections come into the network and connections go out of your network via the internet gateway.
Excellent. Right. Pictures, diagrams, they're worth 1,000 words. Thank you for going over that, Cam.
Absolutely.
Just moving on to the next topic we want to cover today, routing in OCI. Working in OCI, I've heard of many different ways, cloud constructs we could leverage to route local peering gateways, LPGs for short, or dynamic routing gateways, DRGs for short. Could we please take a moment to see what the primary differences are between?
Absolutely. That's actually one of my favorite slides and one of my favorite features. So most of our clouds network engineers, we come from a network engineering background. And we all remember where we had core switches in our enterprise networks and multiple different floors, a core switch, everything would connect to that switch, and we will have connectivity between our floors. Almost the same thing, same thing happens in cloud designs, and the same concept, very similar concept, also exists here. And that is called a DRG. A DRG, or dynamic routing gateway, is exactly the virtual router that you used to have in a traditional network. So in order to have full routing between your parts of your network, DRG is the best solution. It gives you full routing tables and everything, even with complete distribution between your subnets, and you're going to have full connectivity between different subnets. That works for almost every single case. Oracle also supports another construct, and that is the LPG. LPG is not as scalable as a DRG, but provides low latency connectivity between two VCNs. So if you need basic connectivity between two VCNs, in that case, you could use an LPG, and that works fine. But if you're talking about a large design that you want to keep it as scalable as possible, you want to expand that design in the future, using a DRG is probably a better choice. Once again, a DRG is very similar to your core switch in your traditional network, and an LPG is a basic construct to provide connectivity between two VCNs. It basically gives you peering between two VCNs, and resources in those two VCNs can talk to each other.
Thank you, Cam. I really love how you tied it back into traditional network engineering on campus. It really paints
exactly
for us. So dynamic routing gateways, they sound like they're much more scalable, a layer 3 construct, managed by the customer, but the underlyings are hidden deep within OCI. Local peering gateways, peer-to-peer between VCNs. So since both are essentially performing the same function, is there a time that I would prefer an LPG over a DRG, considering DRG seems to be more scalable?
That is an excellent question. Let me just expand your question a little. And let me talk about two different cases where you would prefer one over the other. LPGs are not full-blown routers, so they do not really process the packet a lot. So for ultra low latency designs, once again, for ultra low latency designs where the customer really cares about milliseconds and microseconds, I would rather an LPG. So in those cases, probably I would recommend an LPG to my customers. But keep in mind, a dynamic routing gateway is a full-blown router. Yes, it might introduce very slight latency to your design, but it provides full routing, and that is the construct you need to bring your VPN connections to your design, your FastConnect dedicated connections to your design, and that Axcon is a glue to put everything together. If your design needs ultra low latency and it's simple routing solution between two VCNs, LPG would be the right solution. But if you're looking at connecting multiple different VCNs and bringing multiple fast connects and VPN, well, I would go with a DRG.
Excellent. Okay, so perfect. So ultra low latency where we want to shave off even down to microseconds, right? It's
exactly.
These versus the dynamic routing.
Exactly. In 95% of cases, customers can easily get away with the DRG, and that's a recommended scalable way. There is this 5% chance, a 5% design where you want to consider LPG more seriously. And those are cases where the customer absolutely need very, very low latency.
Perfect. And so I think we have a couple of architectural diagrams. Just want to see what the differences are here. So
let's go have a look. Absolutely. Oh yeah, this is an interesting design with an LPG. So as you see here, we have 3 different VCNs in the OCI region. It is peering between VCN A and my larger VCN. There is also peering going on between my VCN B and my larger VCN. So that's a very basic design. It provides complete routing between the VCNs where I have peering, although it's not going to be possible to do any kind of transit routing. So if you were in subnet A, you can't hop on the bigger VCN to get to subnet B, but subnet A is going to have access to the larger subnet, the larger VCN, and vice versa. Exact same thing is happening between subnet B, its VCN, and the larger VCN. So we designed this with LPG, and you can think of this as a very low latency design. However, as you see, this is not super scalable. So if you were to increase the number of VCNs to 20 or 30, the number of LPGs and the peering sessions between those VCNs would absolutely increase and probably would not be very easy to manage.
Understood. So it sounds like it's a one-to-one mapping between the VCNs, and therefore, if we did want, subnet A,
absolutely,
subnet B, we have to create a new local peering gateway connection between the two. So comparing this with our next diagram, dynamic routing gateways, it looks the same. But if we can take a few moments just to go over.
Exactly. In this case, what you want to do, we want to more focus on the left side of the diagram. As you know, we talked about this in the previous slide. A DRG is used to bring FastConnect and VPN connections to your solution. In this particular case, my customer is using FastConnect. So the only way to connect your FastConnect to the rest of your OCI footprint is via a DRG. The customer has a FastConnect between their on-prem and OCI, and that FastConnect lands on my DRG. It's great. On the right-hand side, I have my LPGs and a previous design, no problem. You can absolutely do that. Or if you want to make that 100% with a DRG, that's still possible. You can connect those VCNs to your DRG and provide connectivity between those VCNs.
Perfect. And I think this is a really great segue to our next topic, because I heard FastConnect a couple times, right? WAN type of connectivity and the dynamic routing gateway. So if we were to take a look at that next topic, right, cloud connectivity. So great way to start discussing this. So we've heard of FastConnect, and it sounds like there's VPN as well. Maybe we can take a few moments just to discuss the two and see.
Absolutely. Probably the most commonly asked question by any customer new to cloud, and not just Oracle Cloud, any kind of public cloud implementation, is the difference between these two options. So as you know, still majority of our customers, they have some on-prem implementation. Might be their headquarters, might be the data centers. Either way, they still want to connect those locations to their cloud footprints. In our case, OCI. There are 2 main options. IPSec VPN, the traditional way, we've been using this for decades to build secure IPSec tunnels between locations, site to site, and FastConnect. Well, if you want to use an IPSec VPN, just like before, it's a quick way. Most network engineers can configure this in a matter of minutes and bring up an IPSec tunnel. That IPSec tunnel would provide kind of, quick and dirty solution between those three locations. In this case, my on-prem and my OCI footprints. And that works fine. I mean, once again, it's been around for decades, fully documented, easy to troubleshoot, very easy to implement, pretty quick solution. On the other hand, if your requirement is to have predictable performance and throughput in terms of throughput, jitter, latency, all those things, I would recommend you use FastConnect, which is a dedicated connection, not via the internet, dedicated connection between your locations and OCI. Keep in mind, an IPsec VPN still takes the path via the internet. Many things could happen. Packet loss, unpredictable latency, unpredictable jitter. You're not going to have any of that with FastConnect. Why? Because that's a dedicated connection between you and OCI, and that's probably the main recommended solution to any customer with any serious workload or major production network.
Perfect. That's fantastic. And, Cam, for the viewers that are going to be watching this, so I hear IPsec VPN and my brain automatically thinks security. With FastConnect, does it imply any type of security coming along with it, or is that something you have to build upon it?
That is a great question. Once again, one of the questions that customers ask very often. The answer is no. So with FastConnect, yes, you're going to get a dedicated connection between your on-prem and OCI. That's going to be yours. You're not sharing that with anybody else. However, there is no encryption. There is no classic encryption going on that link. If you want encryption, many customers do, then there are other ways to provide encryption. But natively, having a dedicated connection does not mean that connection is going to have any kind of encryption. Although with the first option, IPsec VPN, it does mean you're going to have encryption. But with FastConnect, what you're going to get out of a box is just that dedicated connection, predictable throughput, latency, and jitter.
Awesome. Thank you, Cam. And I think the next topic is going to be covering the various ways we could provide encryption on FastConnect. But I do have a couple of quick questions regarding to IPSec and FastConnect. As far as CPE devices, we support quite a many, and I would imagine FastConnect partners as well. We've probably partnered up with many well-known ISPs or service providers. Is that the case?
That's absolutely right. Yes. So there are multiple different ways to bring up a FastConnect connection between your location and OCI. Probably the easiest and most convenient solution would be if you and OCI are in the same physical location, where data centers, we are in 50 plus locations. It's possible to work with a data center owner and just run a cross connect between your cage and our cage. It's going to be dedicated fiber between you and OCI. It's a perfect solution. Although, if you're not in the same data center as us, that's not the end of the story. You can still work with a third party, a carrier. So many of them around. You can find the full list on OCI website and work with them and provide connectivity between your location, wherever you are, to where we are located, or the closest OCI location. So there are different ways to provide connectivity between us and your data center. That's all about FastConnect. With IPsec VPN, really nobody cares. As long as you have access to the internet, you can just run your funnel through the internet and get to the OCI and your DRG.
Perfect. Thank you, Cam. And I think we're just going to take a quick look at both architectures, starting off with FastConnect.
Absolutely. That's a great example right there. My customer here has on-prem connected to the OCI via FastConnect. And for routing purposes, in order to exchange routes between the two locations, we are using BGP. This is, once again, a great solution for any production network. This customer is going to have predictable throughput, latency, and jitter. And this is the ultimate solution for any serious workload. Thank you.
Perfect. And comparing this to Site VPN again?
Exactly. This is the most basic way to implement connectivity between your on-prem and OCI. In this case, my customer is using IPSec VPN. And the IPSec VPN, as I mentioned before, all you need is just access to the internet. Then you build your tunnel and start routing traffic. You're going to have two options of BGP or static routing. And it's just a quick and simple solution. But keep in mind, this solution is good for customers that are not running either serious workload or have other plans in place. For example, they have FastConnect, you're looking at some backup solution. This might work, but I would not use this as my primary solution if I have a production network with serious workload.
Understood, right? Yeah, there's one thing to say about predictability, reliability with FastConnect, dedicated connectivity versus, right, a best effort type of service going in through the internet.
Absolutely, absolutely.
Thank you, Cam. So I think just moments ago, I may have had a question related to encryption and FastConnect. So here we are, FastConnect Security. So it looks like there's two different ways we could achieve this: MACsec versus IPSec over FastConnect. Let's take a few moments, please, Cam, if you could explain this to us.
Absolutely. That's a very great question. Here we come a long way, and there are multiple different iterations of solutions until we get to the point where we are today. So initially, when we started, FastConnect, of course, customers wanted to have encryption. As we mentioned before, FastConnect by itself doesn't mean you're going to have encryption. So customers wanted encryption. One of the possible solutions was to run an IPSec tunnel over your FastConnect to one of your virtual machines, and terminate that FastConnect IPSec tunnel on that virtual machine, and then you're going to have end-to-end encryption over FastConnect between your on-prem and OCI. That was iteration one, kind of generation one solution. We used that for a number of years. A more modern solution that is kind of recommended solution these days is number one, which is MACsec. MACsec is a lightweight layer 2 solution to provide encryption if your device on your end supports MACsec. If it does, that's an absolutely great solution. Low overhead, secure encryption, and fully supported by OCI.
Perfect. Thank you, Cam. And I think I heard you probably answer the question I'm going to ask, but I'm still going to ask it anyway. So IPSec over FastConnect, I imagine it's no different than IPSec across the internet. So the requirements are going to be the same. But are there any considerations for MACsec across the FastConnect circuit?
Absolutely. Absolutely. Yes. Let me just take a quick step back and once again go back to the world of network engineering that we've been living in for decades. Most people know IPSec is a high overhead way of encrypting traffic. If you remember traditional routers, when you had IPSec, along with other features, for example, NAT or quality of service, that would dramatically drop your performance to much, much lower numbers. For example, if your router was able to support 40 gig of traffic with IPSec, with NAT, with quality of service, those features probably wouldn't be able to support more than 4, 5, 6, maybe 10 gigabit per second. So huge degradation in terms of encryption and throughput. But that works. That still provides encryption, provides security that users are looking for. MACsec came along, and with MACsec, now we can do encryption with a lot less overhead. What that means is we're going to have close to line rate encryption, and that works very well. However, there are some, catches. One big point here is MACsec is not supported on every single device. So on your end, you got to look at your router, your firewall, whatever device you're using, and make sure that device supports MACsec. Not just supports MACsec, it supports the options that OCI supports. So there has to be some kind of common ground in terms of the methods of MACsec that the two sides use. That's one point. The other thing is with MACsec, you need to make sure that your carrier, the third party between you and OCI, of course, if you're not going with a cross connect, they also support layer 2 because you don't want them to start doing anything layer 3 in the middle. So if, for example, it's a lease line solution, end-to-end layer 2, that carrier would be able to maintain your MACsec session. So once again, your device supports MACsec, your device supports MACsec options that we support, and the carrier between you and OCI supports layer 2, pure layer 2, and that maintains this connectivity. Some carriers might be doing something else in the middle, in their backbone, and you need to double check with them just to make sure a MACsec session will be maintained and honored by them end to end through their network. But all in all, if all these options are supported, MACsec is definitely a more scalable solution, and that's going to give you higher throughputs.
Excellent, right? Yes, there. Once we do that IPSec overhead, as you mentioned,
Yep.
right, there are certain limitations there. It's still secure. MACsec is still the preferred way. Thank you, Cam. And I think we have a couple of high-level architecture diagrams here. Just
Absolutely. Very simple example here. My customer has FastConnect between on-prem and their OCI footprints. The FastConnect are muted in DRG, as we talked about. They wanted encryption, and they're using MACsec. Once again, very high throughput solution, close to line rate. And apparently in this case, their CPE supports it. On the Oracle side, we support it too. And if they're not using cross-connect, they need to make sure that the carrier also supports layer 2 and they maintain a MACsec solution. That's how this connection remains up and running.
perfect. And comparing that to IPSec over FastConnect.
Exactly. That is that's a trick that we have been using for a number of years before MACsec. The concept is pretty simple. You establish your FastConnect. FastConnect is up. And all you need to do is just to build an IPSec tunnel from your on-prem into your OCI footprint and land that tunnel on one of your virtual machines. In this case, as you see in availability domain 1, I have a virtual machine, and that's where I'm dropping my IPSec traffic. So end-to-end IPSec over FastConnect between my on-prem and OCI.
Perfect. Okay, no, this is great. Again, right pictures are worth 1,000 words, so I'm sure
Absolutely.
that I appreciate this. So coming into our last topic, so we've talked about IPSec, we've talked about FastConnect, and the different types of connectivities to Oracle. However, at Oracle, we also offer our SaaS, software as a service platform as well. And I know there's various ways to connect to this Oracle SaaS infrastructure. We have the internet and versus FastConnect. Could we just go over the differences on the various offerings, and maybe we could take a look at the architecture diagrams right after that?
Absolutely. Well, that's a great topic. Well, matter of fact, Oracle has been a software company for decades and has a very rich portfolio of SaaS applications and offerings. Many of our customers using different business tools, business applications developed by Oracle, and they existed in their customers' data centers for decades on their physical servers. Now, most of those applications exist on Oracle Cloud in the form of SaaS applications. So one of the main questions that customers ask us is, hey, how do we get access to a cloud version of those applications, meaning a SaaS version of same applications? There are two general ways. If you look at this at a very high level, there are two ways. One of them is a very classic way that's true for any SaaS application, meaning as long as you have access to the internet from your home, your office, or airport, anywhere you're on the move, you still can hit the public IP address of that SaaS application via the internet and start browsing your SaaS offering. Simple as that. Of course, it's a path via the internet. The traffic is not taking the best path, not super predictable. You might end up having some packet loss and all the problems we know with the public internet. There is a better way. There's a more reliable solution, as we talked about multiple times during this session, and that's via FastConnect. So if there is FastConnect between your on-prem and OCI, it's possible. to get access to SaaS applications over that FastConnect. And there are two solutions underneath that option. Number one is via public peering, private peering. With the public peering, kind of interesting, when you establish that session, Oracle starts sending you a whole bunch of CIDR blocks to access SaaS offerings in our site. So you will see what's going on in terms of public CIDR blocks, and you can start routing traffic just like, the internet connectivity to those public IP addresses, but this time over a FastConnect. Very simple solution. However, with this solution, you're not going to be able to access resources in your VCN. It's public routing. You hit the public IP addresses of your SaaS offerings, and it's over FastConnect. So it gives you, kind of performance predictability. In terms of improving your user experience, there is another way. If you want to have all the great features of riding over FastConnect, but at the same time still have access to resources in your VCN, there is a way. And that's via private peering. With a private peering, very simple. You build a private peering session between your on-prem and OCI. You ride the FastConnect, you land in your VCN, and you're going to have access to anything in your VCN. The easy part. There is a network and cloud construct that we call it service gateway. All you need to do is to install one of the service gateways in your VCN, and that's going to give you access to all SaaS offerings behind the scene. So one extra hub. Once again, the path is going to be, you go from your on-prem or a FastConnect, hit the VCN, hit the service gateway, go to the world of OCI SaaS offerings. Both are very reliable solutions, different kind of use cases, but they will give you better predictability and, of course, user experience if you compare it to access via the internet.
Perfect. Thank you, Cam. So this is great, right? We have 3 different architectures, 3 different methods of accessing this. And, before I forget, Cam, before we dive into these next portion of the architecture diagrams, if you're an existing Oracle customer and you wanted assistance with any one of these topics, how do the teams, are they available to help with the architectures and things in these decisions?
Absolutely. That's a great question. So our teams, we work very closely with Oracle customers. We are pre-sales, meaning anytime you're trying to bring a workload to the cloud and you have a complex design or a complex decision to make, our team members are more than happy to sit down with you and review your design, come up with the best options, and even help you through the design process to make sure you have an architecture based on Oracle best practices. That's one big offering that we work with many customers. The other solution is our teams also offer a wide range of workshops. Workshops are our way of customer enablement. So we established this relationship with our customers that we sit down with them, we go through our workshops. These are design workshops. We present them the latest solutions based on our latest best practices, and together we design a solution for them. So there are multiple different ways to enable customers and make sure they are following the right architectures and the right best practices. Again, based on the latest standards that we change pretty often as we learn and as we roll out new products.
Thank you, Cam. And we'll just take a quick look at the 3 different architecture diagrams here. So starting off with internet, which I think you mentioned was probably the most basic.
Perfect. Exactly. Oh, yeah, exactly. That's the most basic way to get access to Oracle SaaS offerings. You're my customer on the left from on-prem. They are writing the public internet to OCI services. As you see here, I have a whole bunch of SaaS, all financial applications. I have Fusion apps. I have HCM, ERP, EPM, everything. And keep in mind, that session is still encrypted with TLS. TLS is a pretty reliable solution to provide encryption for web-based applications over the internet.
Excellent. And comparing this to public peering, for example.
Exactly. In this case, my customer had requirements to make sure their performance to access SaaS offerings would be predictable and users will have a better user experience. In that case, they decided to establish connection via FastConnect, and they're using BGP for routing, and they're routing traffic over FastConnect to public endpoints of our SaaS offerings. This is through the public peering. And of course, if you look at my CPE, my customer router, it's receiving a lot of CIDR blocks from OCI for all the resources behind the scene, and they can make decision which CIDR block they want to receive and what kind of service they're interested in.
Sounds good. Thank you. And
Absolutely.
one final. So this is the FastConnect with private peering.
Yes, that is an interesting design. That's the one that we were just talking about. So in this case, the customer wants to have access, not just the SaaS offerings on the right, but also they want to leverage the FastConnect to access resources in their VCN. In this case, they build the FastConnect using private peering. You can write from on-prem over FastConnect, hit the DRG, and get access to anything in your VCN. Beyond that point, there is another construct, as you see on the right, and that's a service gateway. That construct will take you to all the other SaaS offerings behind the scene, including a CM, ERP, and EPM. And it has all the good features of the previous design, meaning predictable throughput, latency, jitter, all those things, great user experience. But at the same time, you will have access to resources in your own VCN because it's a private peering.
Very nice. Thank you, Cam. So I think this brings us to the very end of our topics. So here we are. You're right. Thank you to the audience. Thank you to you for spending your time with us and explaining these architecture decisions. Any last words or final advice for our audience, please, Cam?
Awesome. Thank you so much, Rafi, for hosting this session. Not really. I think we talked about all the key topics that I wanted to cover. But once again, please contact your account team and make sure you have the latest information about our workshops and enablement sessions that we run for our customers. As usual, we're more than happy to work directly with you to make sure you have the best architecture in place.
Thanks. Thank you so much, Cam. So with this said, please come back. We do have a second video discussing the other 5 top architecture decisions in OCI, and that'll be released shortly. Otherwise, thank you for your time. Thank you, Cam, and I hope everybody has enjoyed this video.
Awesome. Thank you.